So this is our last unit on functions. After this, we're going to switch into trig. And this is our exponential and logarithmic unit. Exponential graphs are my favorite. They're those swoopy ones because there's not much to them. It's just swoop. And so I like these ones. These are kind of my favorite. All right, so an exponential function, it means that the variable, which means, the x, is the exponent. So you have something to the x power. So that's something we call the base. That has to be a number. So you would have like 2 to the x or 3 to the x or 5 to the x. There has to be a value there. All right. They have a horizontal asymptote, not a vertical one. They only have a horizontal asymptote. And so there's two ways that this can look. You can have f of x equals a to the x power, a again being a number, there would be a value there. And so we call that exponential growth. Your values are going to keep getting bigger and bigger and bigger. And have you ever heard the saying like such and such grows exponentially? Something is growing exponentially. What they mean is growing really, really, really fast, because an exponential graph goes like it's going to go up really quickly. Or you can have it be a to the negative x, which can also be written as a fraction. We're going to talk about negative exponents a lot in just a minute to make sure we all understand that. And that would be called exponential decay, which means the graph is going down instead of up. I'm going to guess that most of you have taken chemistry or are currently in chemistry. Did you do like, it's usually radioactive decay, like you have an element and then over time it breaks down and you have less and less of it. Okay, like that's what that is. Okay, so that's like where your math and your science, sort of overlap. So we're going to practice doing our transformations. You've done this before, it's review. For exponential, the most important thing to remember is the base number doesn't cause a transformation. It's just there. And that's a crap explanation, but it's just there. It is just there. It doesn't actually do anything. You just have to have a value there. So look at letter A. What number is the base number? 5 doesn't do anything. I usually kind of circle that just to be like, hey, I like kind of check it off my list mentally. That's not going to do anything. But using words like up, down, left, right, stretch, shrink, reflect, all of that, what has happened to this graph? It went right 3, good. Those ones are kind of backwards. And then what else? Up 8, good. Not anything new, we're just reviewing it. So when you look at B, 3 is the base. That's not going to do anything. It's just there. You have to have a number there. Now this one is going to have a reflection. I know those are the hardest ones, like which axis does it reflect over? But before I tell you, does anyone remember which one that's going to be? Y-axis, good, because it's inside the function. It's inside the exponent. So reflect y-axis. And then what else? Yeah, down 4. Perfect. And then for C, 1/7 is the base. That would be decay instead of growth. Would like go down. And so what else happened? There's actually 3 things for this one. Reflect over X, good, because that one's outside. That's hard. That's, in my opinion, the hardest one. Reflect X-axis. Like, it's a reflection, but just which one is it? Now, there's also a 4 out front. So that's, yep, good, perfect. It's taller. So vertical stretch by 4. And then the +9 is inside. So it's kind of backwards. Good. Left 9. So again, let's review, but I just wanted to go over that again. And the base number doesn't do anything. All right. Now, if we're going to do exponential functions, it's important to know like all your rules about exponents. And so it's good to know your squares and cubes. So let's just list out our first 12 perfect squares and our first 5 perfect cubes because they involve exponents, and just to make sure that we know them. The first one is 1. A lot of people forget about 1, but 1 times 1 is 1. All right. Good. 4, 9, 16, 25. I don't want to annoy you by just like saying all of these, but can you list out the first 12? Yeah, good. 36, good. 49. And just make sure that you have them all on there, all right? And if you know them beyond that, that's real cool. I want you to know at least the first 12 without a calculator.
Wait, what's that? No, I want it's like 269.
It's, if you know these ones, you're good. All right, now the first 5 perfect cubes. The first one again is 1. 1 times 1 times 1 is 1. 2 cubed is 8. Good. 3 cubed, 27. 4 cubed is 64. So be careful with that one because it's on both lists. And then 125. Now, I don't have anyone memorize like to the 4th power or 5th power. The squares and cubes are good enough. But 2 is a number that oftentimes you should know, or it's just like helpful if you know that one. Off to the side here, does anyone know what 2 to the 4th is? Because we kind of talked about this. Do you remember that binomial theorem we did with the Pascal's triangle? And we kind of looked at that one's 16, and 2 to the 5th is 32. Those are other ones that's just helpful to know. If you know those, you can always count on your fingers if you don't want to memorize them, but I'm just throwing it up there because we're talking about it. So here we're going to review some exponents. When you have a negative exponent, it reciprocates. It does not make the answer negative, it just flips it over. So when you see that negative exponent, it's just going to flip it. So look at A. What is 3 squared? 9. But since it's negative, it's going to be 1/9. That's all you have to do is flip it over. But it looks scary, and so it throws people off. So I threw a bunch of these up here for us to just practice them. For B, what is 4 cubed?
No.
4 cubed is 64. But since it's negative, it's going to be 1/64. We'll get there. That's what, do you guys understand why I have us practicing it? Because technically this isn't the material. This is the material doing the graphs, but like you have to be able to crawl before you can walk. So we're practicing it. All right, 7 squared. It's 49, but it's going to be 149. Good. Okay. Now 1/5, if you reciprocate that, it would just be 5. 5 cubed is 125. Good. Now this one, if you flip 1/9, you get not good. And then squared is 81. Perfect. Okay. Now the fraction exponents are the roots. The denominator tells you what kind of root. I'm going to say that again. The denominator tells you what kind of root. So if the denominator is 2, it's a square root. So what this is asking you is square root of 36 would be 6. I'm sorry. I can't change what the material is.
Oh, that's not a
Oh, okay, good. I like to keep all the campers happy, but this is what you're learning today. I'm sorry. All right, so 49 to the 1/2 would be 7. So whenever the denominator is 3, that means a cube root. So your cube root of 8 is 2. Now listen, because this one, instead of a 1/3, it's a 2/3. Do you see that there? So it's still a cube root. So your cube root of 8 is 2, and then you square it. So 2 squared is 4. I'm going to say that again. The denominator means it's a cube root. The cube root of 8 is 2, and then 2 squared is 4. So if you want to write it out, it looks like this. Cube root of 8, but then we squared it. And then I threw a 1/4 on there. That would be a 4th root. 4th root of 16 is 2, because 2 to the 4th is 16. You sometimes see the 16 and the 32, which is why I threw them on there. Okay. Now we're going to fill in a table for -2 to the x power. I'm actually going to do this right to left because we'll start with the positive ones. That's a little bit easier. -2 to the 3rd. If you don't want to write this out, you don't have to. I'm just showing you what it is that we're doing. -2 to the 3rd. -2 times -2 times -2. Good. -8. So if you do 2 to the 2nd power, -2 squared. So -2 times -2. Good, it's +4. Do you see that there? Shush. -2 to the 1 is just -2. If you don't want to write these below here, you don't have to. I'm just trying to illustrate what it is we're doing. Now, anything to the 0 power, use brain, then speak. 1. Anything, any number on God's green earth to the 0 power is 1. All right, now we're going to go into the negatives. That means we're going to flip it. You reciprocate. So -2 to the -1. If you reciprocate -2, you get -1/2. You're just flipping it over. But I get that the negatives look scary. It's just intimidating, right? So -2 to the power -2. Well, -2 squared would be 4, but your answer is going to be 1/4. Good, perfect. And then -2 to the -3rd. Well, -2 cubed is -8, but your answer is going to be -1/8. Now, flip back because I have something else to say about that. The reason why we did that is, what do you notice? Good. Okay, that was the first thing I wanted you to notice. There are 2 things here. So do you see how when you go out, this is -1/2 and this is -2, this is 1/4 and this is 4. That's what exponential functions do. Okay. And then what's the second thing you notice? It alternates negative, positive, negative, positive, negative, positive. Come with me on this thought journey. If you tried to graph that, negative, positive, negative, positive, negative, positive, negative, how would you connect them? And would it make a swoop?
Yeah. So it's like,
It would be like this, guys.
oh.
Okay, so you cannot have a negative base. No negative base. That is huge, and we're going to talk about that a lot, that you cannot have a negative base. Someone is going to go, why can't the base be negative? And I'm going to be like, yeah, we actually talked about that already. It's because the values do what's called oscillating, negative, positive, negative, positive, negative, positive, and you don't get an actual graph, you get that big mess, okay? So you cannot have a negative base, and that's why. If you don't care why, that's fine, but just know that you can't have a negative base. Now, you've actually done this before. We're just going to review it. I just threw 2 of them on here, all right? Start with the horizontal asymptote. Did this graph move up or down? It went down 4. Do you guys see that there? So you're going to dot that in at -4 because the whole thing went down 4. And then over here, you can go ahead and put y equals -4. Just do that first. And actually, let's go ahead and do the vertical one as well. What's the vertical asymptote? None. Good. There just won't be one. That's like a gimme answer. Then you want some points. So let's go ahead and make a table. If you pick a number that doesn't turn out pleasant, what will you do? Try again. Try again. What do you want to try? Good choice. I like it. So ready here, I'll talk you through it. We're going to plug in 0. 0 plus 1. Very good. 2 to the first power is 2 minus 4 is -2. Very good. Now I want at least 3. All right, let's do 1. 1 plus 1, 2. 2 squared, 4 minus 4 is 0. Good. And then I would like one more. Do -1. If you said 2, that's fine as well. -1 plus 1, 0. Use brain, then speak. Okay, anything to the 0 power is 1, and 1 minus 4, good, is -3. So go ahead and plot those. You should get a swoop. And then once you connect it, doing the list is easy peasy. Like, you have something to look at. In my brain, there's like a sound effect when I connect it. It's like, so, and I hope I can say that this will be the easy part once you have the graph, because you just look at it and answer the question. What's your domain, left to right?
Oh,
Yep. And hey, guys, that is the answer. For exponential, it'll be all reals. That is the answer. I can't change it because that's what the domain for an exponential is. Range won't be, just watch me point to it. You're going to sweep down to up. You start at what number? -4, but it gets a, why does it get a parenthesis? It's not there. It doesn't actually touch that number. So -4 to infinity. Basically, just don't use any brackets at all this entire unit. Okay? X-intercept. Basically, just look at it. Where is it? 1, 0. Perfect. Y-intercept. 0, -2. Ooh, increasing and decreasing. It only does one or the other. So one of these is also going to say none. It's increasing for the whole domain, which is all reals. Decreasing is none. I love these. These are just the best graphs. A lot of stuff says none. End behavior, it's been a minute. So you just have to remember how to write it. It's limit x goes to -infinity of the function. Limit x goes to +infinity of the function. It's been a little while since we've done that. So, you know, if you're like, hey, I don't remember that, give yourself a break, right? It's been a little bit of time. One end is going to either go up or down, positive or negative infinity. One end is going to go towards the asymptote. And it won't ever actually touch it, but we just say that's where it's headed, right? So where is the left arrow headed? -4. Good. Again, it won't ever actually get there, but it's behavior. Right arrow goes up. So infinity. We're just going to try one more and then we'll do our halfway through break. Okay. So do the asymptote first, or any questions before I do the other one? Or did that sit well? We've done this already this year. We're just reviewing it. Right? Did this graph move up or down? Good. It went up 3. Good. So dot that in at 3. And you can put y equals 3. All right, let's make a table. What do you want to try and plug in? Good. I like it. All right, now stick with me on this one. This is why I reviewed the negatives on the other side of the paper. 0 minus 2. Okay, 1/3 to the -2. If you flip 1/3, you get 3, and 3 squared is 9. I'm going to say that again so that we're all together. 1/3 to the -2. If you flip a third, you get 3. 3 squared is 9. But it's actually -9 plus 3 is -6. If you were like, hey, that was pretty hard, congratulations, you're a normal person. Negatives are hard. Doesn't mean that you are off the hook from doing it, but if you were like, hey, that was difficult, give yourself a break. It was hard. Let's try it again. Let's plug in 1. If you're like, hey, I didn't quite get it, good, we're going to do it again. 1 minus 2, -1. So if you flip 1/3, you get 3, and then 3 to the 1 is 3. Good, but it's actually -3 plus 3, 0. Very good. And then let's plug in 2. Good, you're on top of it. 2 minus 2, 0. Anything to the 0 power, 1, but it's actually -1. Good, perfect. Plot them, you should get a swoop. This one's upside down because there was a negative. And again, once you get that, like doing the list is the easier part because you just sort of look at that and go, oh, here's what my answers are. So domain will be everything. It always will be. That's like the answer. Range for this one, downwards to upwards, it'll be from where to where? Perfect. You guys have got that. Just don't use any brackets at all this unit. Just no brackets. None. All right, x-intercept. 1, 0. Y-intercept, 0, -6. Reading left to right, this graph is increasing. Good. So that's all reals. Decreasing is none. And then set up your end behaviors. And again, one of them will go towards the asymptote. One of them will go either up or down. So where is the left arrow going? Negative infinity, and the right arrow 3. So one of them will be a number, it'll be the asymptote, and then the other one will either be positive or negative infinity.